If we try to believe.
Hello everyone and welcome back to the Boring Teacher. In this session we are going to talk about the universal law of gravitation. In definition in terms of Newton, the law is stated as that every particle attracts every other particle in the universe with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So this is how the universal law of gravitation is stated. So let us understand the meaning of the law. It states that each and every particle in the universe attracts every other particle with a force, with a certain force. Okay, and that force now can be calculated using a formula. Okay, but that force is directly proportional to the product of the masses of the objects involved, and it is inversely proportional to the square of the distance between their centers. Okay, to understand this law in very simple terms, let us take an example. Let us assume that there are two objects, right? Let us say that there is an object A with the center. This is the object A, and let us say there is a smaller object. Let us call it as the object B, and this is the center of that object. And let us assume that the mass of the object A is m1 and the mass of the object B is m2. And as the size are different, we can say that m1 is greater than the m2. We are assuming that the mass 1 is greater than the mass 2. Now, let us assume that the distance between their centers, is represented by d. Okay, the distance between their centers is equal to d. Now, as per the universal law of gravitation given by Newton, it says that the force, let me write it in the form of numerics, in the form of alphabets. Okay, the force is directly proportional to the product is multiplication, so it is directly proportional to the product of their masses, means the mass m1 and the m2, the mass of the objects that are involved. So the first statement of the Newton's law of gravitation says that the force is directly proportional to the product of their masses, and it also says that the force is inversely proportional. Let me write it over here. The force is inversely proportional. Inversely proportional is 1 upon something, right? So the force is also inversely proportional to the square of the distance between them. Simple, right? It says that the statement says that the force between the two objects is directly proportional to the product is multiplication, product of their masses, that is m1 and m2, and it is also inversely proportional. Inversely proportional means 1 upon something, inversely proportional to the square of distance between them. So f is inversely proportional to d square. Now, if we combine both of these equations, what do we get? Combining both of these equations, we get f is directly proportional to m1 multiplied by m2 divided by d square. This is what we get when we combine these two equations. Now, as we know, if you want to remove the proportionality symbol and place an equals to sign, if I want to write it in this form, f equals to, if I want to remove this proportionality symbol and write an equal to sign, then I have to place a constant, right? I have to put a constant. So f is equal to, let us assume that the constant is capital G. Now we will talk about capital G. What is the capital G, meaning of that, the definition, what is the unit of it, the value of capital G. Okay, so f is equal to capital G. Rest of the things remains the same, m1 m2 upon d squared. Now the capital G is, as it is a constant, it is known as universal constant. It is known as universal constant of gravitation. It is known as universal constant of gravitation, and as the name suggests, it is constant in the universe. That means wherever you go, the value of capital G will not change, right? The constant that we have taken, universal constant of gravitation, it means the value of capital G will not change anywhere in the universe. Fine. Now talking about the value of the constant, as it is a constant, the value will also be remaining same. We have to remember the value. The value of G, the numeric value of G is 6.673 multiplied by 10 raised to minus 11. Okay, this is the value, the numeric value of the constant capital G. Now it has some unit also. Now how to define the unit? For that, I want you to look at the formula. Okay, F is equal to capital G m1 multiplied by m2 divided by d square. Now let us take G as our hero. Okay, G remains at that place only, equals to F is at its own place. D square in division goes to multiplication, so F multiplied by d square, and m1 m2 in multiplication goes to division, so divided by m1 multiplied by m2. Now talking about the unit, the F is the force. That means the unit of force is Newton, so Newton multiplied by d square. D is the distance, so distance, the SI unit is meter, so meter squared, divided by mass 1 into mass 2. Mass, the SI unit is kilogram, so kg multiplied by kg, that will be the unit of G, right? Okay, kg multiplied by kg will become kg square. So finally, ultimately, the unit of capital G becomes Newton meter square per kg square. This is the unit of the universal constant of gravitation. So if I write it, it looks like this. G is equal to 6.673 multiplied by 10 raised to minus 11 Newton meter square per kg square, right? So let us have a recap of whatever we have done. The Newton's universal law of gravitation, it states that the force between any two objects is directly proportional to the product of the masses of the objects that are involved, and it is inversely proportional to the square of the distance between their centers. Now on combining these two equations, we get F is directly proportional to m1 multiplied by m2 divided by d square. To remove the proportionality constant, placing an equals to sign, we have to take a constant. So F is equal to capital G m1 multiplied by m2 divided by d square, where this capital G is known as the universal constant of gravitation. The value of capital G is equal to 6.67, sometimes taken as 6.67 multiplied by 10 raised to minus 11, the unit Newton meter square per kg square. So this is it about the Newton's universal law of gravitation. Now one question coming to my mind right now after understanding this law is that if every object in the universe attracts every other object with a certain force, that means as an object 1 I consider my body, and as an object 2 I consider the moon. Okay, does that mean that I'm standing on the earth right now? Let us consider this as the earth, and I'm standing on the earth, and the moon is revolving around the earth in a specific orbit. Okay, let us say that the moon is revolving like this. Okay, so does that mean that I am being attracted towards the moon, or the moon is attracted towards me? Does this really happen? Does the meaning of the universal law of gravitation suggest this, that I and the moon attract each other? Then why don't I or the moon gets attracted towards each other? This is the question coming to my mind. Okay, to find out the answer of this question, you have to look to the next video. Thank you for watching.
If we try to believe in anything greater than a